Hi everyone, my name is Wei. I'm from the course of Electronic Network Design. My matrix number is 211302217. Today I want to share and present about the topic of body system and binary tree in operating system. First of all, before we discuss about the body system allocation and binary tree, let me simply briefing about the memory management. The memory management is used to specify the request for the memory allocation. This system must allocate enough unallocated memory and assign the request to the process. One of the examples for memory management is body system allocation. So let's assume that n is equal to size of the request. If the n is smaller than the smallest allocation unit, the system will set n to be the smallest size. And then the system will round n up to the nearest power of 2, and it will select the smallest k, which is 2 power of k is larger and equal than n. If there is no free block of the size of 2 power of k, the system will allocate a block of size 2 power of k plus 1 and split it into 2 free blocks of size 2 power of k. And last, the system will return the first free block of size 2 power of k in response to the request. So let's assume that n is equal to 20. If the nearest power of 2 of 20 is 32, which is 2 power of 5. If there is no free block of size 2 power of 5, the system will allocate a block of size 2 power of k plus 1, which is 2 power of 6, and split it into 2 free blocks of size 2 power of 5, and return the first free block of size 2 power of 5 in the response to request. Next, I will show the fixed and dynamic partitioning. This table shows the difference and the characteristic of fixed partitioning and dynamic partitioning. For fixed partitioning, it does not utilize the main memory effectively, while for the dynamic partitioning, it utilizes the main memory effectively. This is because fixed partitioning there is more easier to implement compared to the dynamic partitioning. In fixed partitioning, there is limitation on the size of process. In dynamic partitioning, there is no limitation on size of process. And now, I will show you an example of body system allocation and the flow of the memory allocation. In this example, I will use the total 128 of bytes for the memory space. For first instruction, there is allocate the 20 requests. The nearest power of 2 for 20 is 32. But for the block before that, there is no free block of 32, and the system will allocate it to the size of 2 power of k plus 1, which is 2 power of 6, 64. And the system before that also does not have the block of 64. And the system will allocate it into the block of 2 power of k plus 1 of 64, which is 128, and split the 128 into 2 blocks of 64. And the first block of 64 will split again to the 2 blocks of 32. And the first block of 32 will allocate the request of 20. This is according to the rules of the body system allocation. And for the next instruction, there is allocate the request of 15. The nearest power of 2 for 15 is 16, and for the block before that, there is no free block of block 16. Then the system will allocate it to the block of size 2 power of k plus 1. The 16 is 2 power of 4, so the system will allocate it to 2 power of 5, which is the 32, and the system will split the block 32 to the 2 block of 16, and the first block of 16 will allocate it to the request of 15. And for the next instruction, there is allocate the request of 10, and the nearest power of 10 is 16 also. So for this request, it can directly allocate it into the block of 16, which is the block 16 remainder before that from the block of 32, and it does not have to split the block from the block to power of k plus 1. And for next instruction, let's allocate the request of 25. The power of 2 for 25 is 32 also. So for the block, free block before that, there is no block of 32, which is 2 power of 5. And the system will allocate it to the block size of 2 power of k plus 1, which is 2 power of 6, 64, and split the block of 64 to the 2 block size of 2 power of k, which is 2 power of 5, 32. And the first block of 32 will allocate it the request of 25. And for next instruction is the instruction of release. It release the request, and this instruction, it has to release the request of 20, which is the 20 request it allocate in the first row of the instruction. So the system will find the place which allocate it the 20, and the system find the place allocate the 20, and it will release the whole block of the place which allocate the request. And the block of 32 is allocate the request 20 before that, so this whole block will release it, and it will turn available for the next allocation for the request. And for next instruction also release the request of 10, so the system will find the place which allocate the request of 10 before that, and release the whole block of the place allocated. And for the next instruction is allocate the 8 request. The nearest power of 2 for 8 is 8, but the block before that, there is no free block of size 2 power of 3, which is 8. So the system will allocate it into 2 power of k plus 1, which is 16, and split it the 16 into the 2 block of 8. And the first block of 8 will automatically allocate the request of 8. And for the last instruction, that is allocate the 30 request. The nearest power of 2 for 30 is 32. So before that, the system have 2 block of 32. So for this instruction, the request will select the first 32 blocks and direct allocate it in 2. And last, I will show the binary tree. Binary tree show the query of memory allocation, which is body system allocation. For the white circle, there is the root block. For the red circle, there is a block which occupies the request. And for the yellow circle, there is the free blocks which is available for the next allocation. And in the example just now, we use the total memory space with 128 bytes. And for this row of instruction, there is allocate the 20 requests, 15 requests, 10 requests, and 25 requests. So for the 20 requests, the nearest power of 2 for 20 is 32. So the system will split from 128 to 2 block of 64, and split again from 64 to 2 block of 32. And the request of the 20 will allocate it into the block of 32. While for the 15 and 10, the nearest power of 2 for them are the 16. So there is no free block for 16, and the system will split it from the 32 to the 2 block of 16, and this request will allocate it into the block of 16. And for the allocated 25, there is also same, which is the nearest power of 2 for 25 also 32. So the system will allocate it into the block of 32, and the another 32 will let it available for the next allocation. That's all of my presentation today. Thank you for listening. Thank you very much.